Alright, this is our video for section 5.2 and it's on polynomials. And the first thing we're going to do is get a definition for a polynomial. And a polynomial is a monomial, which we talked about in our 5.1 video. A monomial or the sum of monomials, which means we can add and subtract the monomials together. Because if we subtract them, it's really adding a negative. So it still falls under the sum here. Okay, a monomial or the sum of monomials. And again, that means we can add or subtract this time monomials together. Okay, now there's one quick rule. To be a monomial, it has to have positive whole number exponents. And we talked in our monomials video about the rules of exponents, how to get those exponents to become positive. If you got a negative one, that was one of our rules of exponents. So if it's got a negative exponent, you could move it to the bottom and make it positive. We've got 4 examples here, and what I want you to do as we work through them is tell me yes or no whether they are polynomials. Now, the first one here, we're adding 2 things together. We've got 2a plus 5b. That means it's got 2 terms. Okay, everything that's being added or subtracted together is a term. So here we have 2 terms. If we look at our exponents, they're not written in here, but each one is an exponent of 1, which is a positive whole number. So yes, that is a polynomial. Second example, we've got 2x to the third minus x squared plus 3x to the fourth minus 7. Well, we've got 4 different things here. The 2x cubed, the negative x squared, the positive 3x to the fourth, and the minus 7. Since there are 4 different things, that means there are 4 terms here. Now to figure out if it's a polynomial, again, we look at the exponents. Well, our exponents are 3, 2, and 4. They're all positive whole numbers, so yes, this is a polynomial. Next one, we've got c to the fourth minus 4 times the square root of c plus 18. We've got 3 things here. C to the fourth minus 4 square root of c plus 18. So there are 3 terms. And we want to check and see if we've got positive whole number exponents. Well, I agree that the 4 is. And we've talked about this before in class, that a square root is really an exponent of 1/2. So that's really c to the 1/2. 1/2 is not a whole number. So this is a no. This is not a polynomial. It does have 3 terms, but it's not a polynomial. Last one here, 3s. We've got 1 thing there, so it has 1 term. Nothing's being added or subtracted to it. It's just all grouped together. That is a monomial. Okay, 1 term is a monomial. And the exponent there is a 1. So yes, it's a polynomial. Okay, make sure that you can identify the number of terms it has and whether or not it's a polynomial, whether it meets this rule up here that it's got positive whole number exponents. Real quick, we've got a couple vocabulary words here. Monomial we went over last time, what that is. For today's purposes, we're going to think of it that it has 1 term. There's 1 thing there. A binomial has 2 terms. Trinomial has 3 terms. Okay, easy way to keep these straight. Like if you had a unicycle, it has 1 wheel. Now this doesn't say unicycle for monomial, but mono means 1. Okay, so it has 1 term. Bicycle has 2 wheels. Notice we've got binomial here, has 2 terms. A tricycle has 3 wheels. Trinomial has 3 terms. Polynomial is a general term for anything after that, okay? And it just means that it has many terms, okay? So monomial, binomial, trinomial all have specific names. Anything after that we just call a polynomial. So if it's got 10 terms, it's a polynomial. If it has 22 terms, it's a polynomial. Now the degree, we're going to get its definition here too. To get the degree of a polynomial, you add the exponents on the variables, not on the coefficients. Okay, not on the number part, just on the variables for each term. And then the highest value is the degree. Okay, so we got 3 examples here. Notice two of them are the examples from above, the 2 that were polynomials. Okay, the first one here, we've got 2a plus 5b. Well, the exponents aren't written in there. They're understood to be 1s. We could add them in there if we need to. So the first term has a value of 1 because there's only one exponent there. Second term has a value of 1. So the degree here is 1. That's the biggest value on the terms. The second example has 4 terms in it, like we learned above. The first one has an exponent of 3. Second one has an exponent of 2. Third one has an exponent of 4. And the last one here has no variable. Okay, so its exponent would be 0. It's like saying we could have x to the 0, which is really 1. We don't write that in, though, but it's understood that we could. Now, we want to look for the biggest value here. Well, 4 is the biggest, so our degree is 4 on that second example. Last example, notice we have more than one variable in each one. First term is 1/4 c cubed d to the 5th plus 7a to the 6th c to the 4th. If we've got more than one variable, we need to add all the exponents together. So for this first term, we got to add the 3 and the 5, and we would get 8. On the second term, we have to add the 6 and the 4 because those are the exponents on our variables, and we would get 10. Now for the degree, we want the biggest value. Well, 10 is the bigger one, so the degree on that last example is 10. Now your problems today, they will ask you for degree, they will ask you for how many terms it's got and whether or not it's a polynomial, but the majority of them are going to be to simplify problems, simplify polynomial expressions. And what that means to simplify is that you're going to add or subtract or even multiply things together and then combine like terms, which is something we should be familiar with. Now, like terms, just in case we've forgotten, means that they have the same variables with the same exponents. That means that you can't combine an x squared plus an x cubed. Okay, they have to stay separate. While they have the same variables, they both have x, they have different exponents. They won't combine. One other thing to remember is that when we write our answers, we write them in descending order of exponents. So we start with the biggest one, and we work our way down. If we're looking at that example I wrote underneath the same variable, same exponents, it's actually written backwards because we should start with the biggest exponent. We should start with the x cubed and then go to the x squared. Okay? Those are the rules we need to remember to simplify. Now, we've got 6 examples here we're going to look at. Most of them you should be familiar with, especially these first ones. Okay, example 1 here, we've got 5a squared plus 4b cubed minus 3a squared plus 7b cubed. And we want to combine like terms here. We're going to add things together. Now remember, they have to have same exponents, same variables. Well, we've got an a squared and an a squared. We have a b cubed and a b cubed. Alright, the cube is bigger, so we're going to start with that. 4b cubed plus 7b cubed. Well, 4 plus 7 is 11, so we get 11b cubed. And then we have 5a squared minus 3a squared. 5 minus 3 is 2, so 2a squared. That's it, there's our answer. We can't go any farther because they have different variables with different exponents. Example 2. We have two trinomials here and we are subtracting them. We've got the quantity 2a cubed plus 5a minus 7 minus the quantity a cubed minus 3a plus 2. Now, before we can do anything, we got to get rid of that minus sign between them. And there's really a 1 out in front of that set of parentheses. So what we are going to do is distribute that negative 1 to everything in the set of parentheses. First set's not going to change. This first set does not change because there's no negative out in front of it. The second set changes though. So it's going to become 2a cubed plus 5a minus 7. Again, the first one doesn't change. Then you have negative 1 times a cubed, which is going to be minus a cubed. Negative 1 times a negative 3a. Two negatives, when you multiply them together, become positive. So it's positive 3a. Negative 1 times positive 2 is going to become minus 2. And now we look for things that we can combine. Well, there's an a cubed, there's an a cubed. There's an a, there's an a. And then we have two constant numbers here, the minus 7 and the minus 2. Let's combine it all. Let's simplify. 2a cubed minus a cubed, well, that's just a cubed. 5a plus 3a is really 8a. And then minus 7 minus 2. Negative 7 minus 2 is minus 9. And there's the answer to our problem. We can't go any farther because a cubed, an a, and then a constant, they don't have anything in common. They have different exponents on each one, so we can't do anything for that. The next example is going to be multiplication. So the first one was addition. The second one was subtraction. The third one is multiplication, and we've got a negative y on the outside of a set of parentheses. So what we're going to do is distribute that negative y through to each part. We've got negative y now times 4y squared. Remember, when we multiply things with the same base, we add their exponents, and the exponent on that negative y is really a 1. So we have negative y to the first times 4y squared. Well, negative 1 times 4, that's negative 4. We've got to add those exponents now. 1 plus 2 is 3. The next term, we have negative y to the first times positive 2y. Well, negative 1 times 2 is minus 2. Y to the first plus another y to the first is going to be y squared. Last term, negative y to the first times negative 3. So it's really negative 1 times negative 3, which is going to become positive. And the negative 3 doesn't have a y on it, so we're just going to tack the y from the outside to the end of it. And then there's our answer. Notice we can't combine any farther again, because one's cubed, one's squared, one's got an exponent of 1. And they all have different exponents, so we can't do anything. They can't combine. Problem 4 here. You should have seen this before. This is a FOIL problem, and FOIL stands for first, outer, inner, last. So we're going to multiply the first two terms together. 2p times 4p, well, that is 8p squared. Make sure you multiply. Don't tell me it's 6p squared. 2 times 4 is 8. We do the outside 2. 2p times positive 1 is going to be 2p. Inside 2, 3 times 4p is 12p. And then the last 2, 3 times 1 is 3. Now make sure that you multiply. That's the common mistake on this problem. You guys know how to FOIL, but the common mistake is that you'll add a couple of those terms together because there's plus signs there, or you'll subtract them if there's minus signs. You have to multiply the whole way through. Now we look at this, the 8p squared plus 2p plus 12p plus 3, and we see if we can combine anything. We can combine those two in the middle. We've got 2p plus 12p, which is really 14p, so our answer is 8p squared plus 14p plus 3. And that's the final answer to that problem. Example 5. This is a common problem, okay? We've got the quantity 6r minus 1 squared. Now what I want you to do, most people will just take that 2 and they'll put it on the first term, put it on the second. That's not what you do for this, okay? It's not a distributive problem. That 2 does not get distributed through. Think about something like 5 squared. And to figure out what 5 squared is, we multiply 5 times 5. Well, we're going to use that same idea here. We're going to take this quantity and multiply it by itself. So it's going to become 6r minus 1 times itself, so times 6r minus 1. Now it's a problem like number 4. It's a FOIL problem, okay? We do the first two. 6r times 6r, well, that's 36r squared. 6r times negative 1, it's negative 6r. The inside 2, negative 1 times 6r, that's another negative 6r. And then the last two, negative 1 times negative 1, is positive 1. And we can combine the two in the middle. So we get 36, not r cubed, r squared. Negative 6r minus 6r, well, that's going to be negative 12r plus 1. And there's the answer to our problem. Last one, number 6. You're going to use multiplication here, but we've got a binomial times a trinomial. And this is where it gets a little tricky, because each term in our binomial has to get multiplied to every term in our trinomial. Now, I call this the lobster claw, because that's the shape it's going to look like. Okay? We are going to start here with the a, and that a has to get multiplied to each term in the trinomial in the second part. So we've got a times a cubed. We add those exponents, and we get a to the fourth, because there's really an exponent of 1 here. So it's 1 plus 3. Now we do a to the first times 3a to the first, and that's going to be 3a squared, because we add the exponents. 1 plus 1 is a 2. Now we take that a to the first, and we got to multiply it by the negative 4, the last term there. A times negative 4 is going to be negative 4a. Now the second part is that we have to take the second term in our binomial, and we've got to multiply it to each term in the trinomial. So we're going to do 2 times a cubed, which would be 2a cubed. 2 times 3a to the first. Okay, we multiply the 2 times the 3, that's 6a to the first. And then the last one, we have 2 times a negative 4. Now make sure you multiply that again. Don't add and subtract. 2 times negative 4, well, that's negative 8. Now we look and see if there's anything we can combine. Anything that's got the same exponents. Well, there's a to the fourth. I don't see any other a to the fourths. There's an a cubed. I don't see any other a cubes. There's an a squared. Right here, though, there's a negative 4a and a positive 6a. Those two will combine because they both have an exponent of 1. And then we have the minus 8. Now remember, we write this in descending order. So when we write it, we should start with the biggest exponent, which is a to the fourth. And then we're going to go to the next one, which should be 2a cubed plus 3a squared. Now these two we're going to combine. Negative 4a plus 6a, well, that's really 2a, and then minus 8. And then that's our answer to the problem. It won't simplify any further because there's an exponent of 4, an exponent of 3, an exponent of 2, an exponent of 1 that we don't have to show. We don't have to write that 1 in there. And then a constant. And you can't combine any of those because even though they have the same variables, they all have different exponents. And those are your examples for polynomials. Those are your notes for section 5.2 on polynomials.